Let's take a look back in time to the pre-Agile landscape. As the famous American astrophysicist and cosmologist Carl Sagan once said, you have to know the past to understand the present. So let's look at a historical accident that led to the creation of the waterfall development process. Meet Dr. Winston Royce, an American computer scientist who was a PhD from the California Institute of Technology and who worked as a director of Lockheed Software Technology Group. He was a pioneer in the field of software development. In 1970, he wrote a paper titled Managing the Development of Large Software Systems, which mistakenly came to be known as the source of the waterfall development methodology. Actually, in this paper, Dr. Royce was pointing out that a phased development process was, quote, risky and inviting failures. However, mistakenly, probably due to misinterpretation, this paper is attributed for the birth of the waterfall process. And by extension, Dr. Winston Royce is thought by some as being the father of the waterfall methodology. Waterfall was the dominant process being used to build software systems all throughout the 70s, 80s, and most of the 90s. This is not to say that this was the only existing software development process during these decades. Several other processes did exist during this period, such as software prototyping, which was around from the early 70s, rapid application development, which was created in the 80s with formal introduction in 1991, iterative and incremental development, IID, which came about in the 60s, extreme programming, which was introduced in 1999, Scrum, which was introduced in 1995, Rational Unified Process, RUP, which came about in the late 90s, etc. So even though there were other processes in existence around this time, the most common process being used in this time for building software systems was the waterfall methodology, also known as the phased development process or methodology. So that is a brief history of the birth of the waterfall development process. Next, I think it'll be helpful to do a quick review of this process and its key drawbacks as a refresher. So this is a classic picture that represents the waterfall process. The first phase is called the requirements phase. In this phase, system requirements are gathered and documented typically by a business analyst. The next phase is known as the design phase. In this phase, the developers review the requirements and come up with a logical design for the software application. For those of you who may not be techies, think of design as the plans that an architect comes up with before actually working on a home or a building. The next phase is known as implementation phase. In this phase, the developers actually write the code to implement the software system based on the requirements and design which were completed in the preceding two phases. Then comes the verification phase. In this phase, the testers or the quality assurance team tests the software system to ensure that it meets the requirements which were documented in the very first phase. There can be more than one testing phases, such as integration testing phase followed by system testing phase. Once all testing is completed, the application code is deployed into the production environment in the deployment phase. And finally, after the application is deployed, the software system is available to the users or the public, and that's when the maintenance phase starts, when the users use the software system and any problems, issues, or defects they may find are raised to the development team, who are then expected to fix it. So that is a quick summary of the waterfall development process or methodology. Now let's talk about some of the key drawbacks of this process. This is a rigid process. All phases are dictated by the outcome of the requirements phase. At the end of the requirements phase, the requirements document is signed off on And from then on, each of the subsequent phases, design, coding, testing, and even deployment, are expected to follow precisely the requirements as specified in the requirements document, even if by then the actual end user needs or the business conditions have changed. This process has a very high cost for any change. Every now and then, an urgent new requirement or change will inevitably get requested by the users. But the cost of implementing any change is very high in the waterfall process. This is partly due to the way in which coding takes place in this process, which is in large batch sizes, and partly due to the overhead of additional documentation and approvals that are needed in this process. Another reason why waterfall process incurs a very high cost of change is from the fact that they fix defects very late in the game. Defects, as you know, are found by testers in the testing phase, which is a phase which takes place right towards the end of the life cycle. Studies have shown that the cost of fixing defects increases exponentially the later they are found in the development life cycle. This process creates waste. Business users realize that if they don't get their entire list of features and functionalities into the requirements document before the document is signed off on at the end of the requirements phase, it'll be very difficult for them to get any of their features into the document after the sign off. And this creates a sense of false urgency or a tendency by the business users to include their entire wish list of features and functionalities into the requirements document, even if many of those requirements or features might be of marginal use or no use at all to them. As a result, software applications that are built using the waterfall process end up having a lot of features that are rarely used or never used. Studies have shown that software applications that are built using waterfall end up having up to 80% of features that are rarely used or never used, and only 20% of features that are used frequently. Another source of waste in this process comes from the fact that this process relies heavily on creating documentation at each phase as part of either the phase gate checkpoints or status update documentation or intermediate deliverables such as test plans. This process also has high risk and uncertainty. Since in the waterfall process the actual software application is demonstrated at the very end of the life cycle to business users, the business users don't get to see the working software application until all the testing is completed. This creates a high risk and uncertainty since by that time, if business users don't like what they see, or if business conditions have changed, too bad. It's too late to do anything about it. The software application has to be released into the production environment anyways. This process also creates silos and de-emphasizes or discourages collaboration. As you can see, each phase of this process requires only one type of functional role to produce the output of that phase. In the requirements phase, it is only the business analysts that are busy documenting requirements. In the design phase, it is only the developers that are busy creating the design document. In the implementation phase, again, it's just the developers that are needed to write the code. In the testing phases, it is just the testers that are needed to test the system. And finally, in the deployment phase, it is a whole another team of deployment engineers that actually deploys the application code to the production environment. This creates silos based on functional roles, and there is little or no impetus for each of these roles to collaborate with each other throughout much of the life cycle of development. The only time when these functional roles might interact with each other is towards the end of the testing phase, when defects are found by the testers, and in order to fix the defects, the testers work with the developers with some occasional input from business analysts. However, even such interactions are imbued with protecting one's turf, playing the blame game, etc. In other words, even then, interactions are not collaborative, rather they are more adversarial in nature. This process tax utilization, not value delivery. The waterfall process uses on-time and on-budget completion of projects as a measure of success. This leads or encourages the managers to focus incessantly on utilization. And as a result, they try to ensure that all of their resources are busy up to their necks with work throughout the life cycle of development. Studies have shown that high utilization is the enemy of flow and value delivery. If you load up your resources with work just to ensure that they are busy at all the time, it will leave no time for innovation and creative thinking. Instead, people will be always in a rush to finish up their tasks with the mindset to just get something done. And this attitude leads to poor quality output, not to mention it also causes low morale and low engagement among team members. Alright, before I end this lecture, I do want to share with you a definition of a common term that we will be using in upcoming lectures, and also it's a common term in the world of software development. The term is Software Development Lifecycle, or SDLC for short. Software Development Lifecycle, or SDLC, refers to any process that is used to design, code, test, and deploy a software application. So a SDLC can be a waterfall process, or it can be any of the Agile processes. Please note that some online websites use SDLC to refer to only the waterfall process. This can be misleading since SDLC refers to any process. It can be waterfall, or it can be any of the various Agile processes, which we will cover in the upcoming lectures. Alright, so that's it for now. See you in the next lecture.